A very good morning, ladies and gentlemen. The video displayed was from Virtual Science Fair 2021 sponsor, and we would like to extend our sincerest gratitude towards Kenanga Investors Berhad for your sponsorship. So, ladies and gentlemen, on behalf of the organizing committee, I would like to welcome you to University Malaya Science Exhibition, brought to you by Virtual Science Fair 2021. I am Thainmoli Segarin and I will be hosting the event today. And before we get into the core of the event, the introduction of various courses through University Malaya student bodies, allow me to introduce the student bodies we have on board today. The American Chemical Society, chapter, Geological Society of Malaysia, another student chapter, as well as Pure Geology. And first up, we have the American Chemical Society, chapter. Thank you, Ms. Noreen Hanis Zohaira binti Nur Shamsul Azman and Ms. Deepika Lakshmi Aravindan for agreeing to join us today. So without further delay, I'd like to welcome our presenters, Ms. Noreen Hanis Zohaira and Ms. Deepa Lakshmi, to begin their sharing session. The virtual stage is all yours.
Thank you. All right, so yes. Okay. All right. Assalamualaikum and a very good morning to everyone. So my name is, as you can see there, Noreen Hanis Zuhaira binti Nur Shamsul Azman. Quite long, but you can call me Hanis. I'm a first-year degree student doing Bachelor of Science in Applied Chemistry. So I think it is very imperative for me to share my experience today as a freshie that just got into this chemistry field. I am so glad to be here today. So thank you to Virtual Science Fair for conducting this kind of exhibition. Next. All right, so this is our overview of what we are going to share with you today. Introduction, a little bit of introduction, why chemistry, facilities, challenges, opportunities in chemistry, in science we explore, quiz time, and finally we will have a Q&A session where you guys can ask us about anything that you guys would like to know more about chemistry. Next. All right, so general information. So what is actually ACS student chapters? So ACS, as the MC has mentioned before, stands for American Chemical Society. ACS student chapters are basically the organizations for students with an interest in the chemical sciences under ACS, which is based in the United States. It is a non-profit scientific organization. So specifically for us, ACSUM, I'm sorry, next. Yeah, so we are from ACSUM, meaning that we are the official student society under the Department of Chemistry, Faculty of Science, University of Malaya. Next. Okay, so just for your information, we have just been established on October 2019, where our members consist of course, chemistry students. But we're not just focusing on undergraduates. We also have postgraduate students who are being the member of this society. And although we are relatively a new society, we are actually have been awarded by a prestigious award from ACS itself, which is the Honorable Mention Awards last year. And just to a little bit of promotion here, our next event in the near future would be we have planned some events. So basically they are ACS special issue, new journal where we are focusing on water, conference with ACS publication, and we also will be going, we also will have ACS Chem Fest, where we usually held it annually on October and also November. And this festival always usually will always involve public. All right, so now I want to talk about chemistry as a course. So basically in UM, we are offering two courses of chemistry, namely pure chemistry and also applied chemistry. So the most common question that we will get is, what is the difference between pure chemistry and applied chemistry? So when we talk about pure chemistry, um, we are basically studying more about the theory of chemistry, whereas in applied chemistry, we are learning on the theory and how to apply them, just as the name suggests, right? Applied chemistry, we are applying the theory that we have learned. And of course, as a science course, we have two modes of learning where the theory will be taught in lectures, and also we have the practical sessions that will be taught in lab sessions. Next, yeah, I think I will pass to my friend over here, Deepa.
Hello, everybody. A very good morning. The thing is, I've been doing my undergrad degree. I finished my undergrad in UM. I did applied chemistry. Now I'm a master's student by research. So I'm very well used to the chemistry department and how things work there. So basically, we are under Faculty of Science, and I precisely at chemistry department. And for the master's degree, particularly in UM, there are two different ways that you can obtain a master degree. Firstly, it's through research, and second is coursework. For the coursework, it is pretty much limited. You have a few classes and as well as lab-based practical classes. Whereas for research, it's all time. You'll have to work as an research assistant, where you'll have to help the lecturers with the research papers, mostly based on conducting experiments in the lab and so on. So both are pretty much they are very unique in their own ways. When you look at the Masters of Science in Instrumental Analytical Chemistry, basically you'll be looking at in depth of analytical chemistry, where you talk about accuracy and precision and measuring the chemicals and everything. All those comes under Masters of Science in Instrumental Analytical Chemistry. And these all the courses particularly that's offered by Faculty of Science under the chemistry department are all aggregated by the Royal Society of Chemistry, which is which where whenever you hold these type of degree, you have the basis to tell people that you are aggregated from a really high society of chemistry, meaning like they know the standard of how the chemistry is taught, and each courses they hold the value of how much information that's provided. So basically, it's basically the degree that you hold is of much importance because they have the value of what a degree says. So I would assure that these degree are very much useful if you are planning to continue your studies in the field of chemistry. Yes.
All
Why
right, so
chemistry?
now,
Yeah.
okay,
Go on.
um,
Yeah.
okay, so now we are down to the biggest question of why we are pursuing chemistry, right? Because I think in everything that we do, the biggest question is always why, because the answer to this question will either bring us closer to that thing that we want to do or bring us away from that, right? Depending on the answer. So today I want to share with you why? The answer to this question, why chemistry? So, actually, I think it is not too much for me to say that chemistry is the bridge of all science, right? It is the essence of science. Why? Because we cannot run away from chemistry. When, for example, if you have already decided to delve into the science field, you cannot run away from chemistry. For example, we have physical chemistry that links physics and chemistry. We also have biochemistry that links biology and chemistry. So that's kind of a simple example that I can give to you. That means everything revolves around chemistry. And as you can see here from the mind maps, right? We have atmospheric science, solid state physics, medicine, all revolves from chemistry. And let's say we want to synthesize something, batteries, plastic, so basically anything, we will need chemistry. So yeah, that's why I say chemistry is the bridge of all science. Deepa, you want to say anything about this?
Yes, I would agree with you, Anis. Like, it bridges most of all the sciences that we hold compared to. physics, biology. No, you cannot deal with one branch of science and say that the other one is more important than the other. So basically they hold all their importance. So I would say, like, if I want to give a brief introduction about why chemistry, I would say, okay, let's take a look around us. What do we have? Everything is like made up of chemicals. And how do we deal with this? How do we understand them better? To understand them better, we'll have to look into them deeply. So there, that at that point, there comes a need for us to understand them better. So to understand, we need study. We need to study them. So typically, that's what chemistry does. So we are going to study the things around us in a way that it gives you facts and you understand them better. It makes life less mysterious. So if it's less mysterious, it's always better, right? If you understand something better, it gives you an feelingness of, you have understood things around you very much. And one thing is, if you understand everything that's around you in a better way, you can apply them to even make things better around you for practical purposes. As you say in chemistry, like, you look around things, the food, the batteries, everything has been evolutionized from the 90s. Everything has been taken through a period of time where progress have been seen on how to store food, let's say. Or plastic, let's talk about plastic. So how far have we come? When they started producing plastic in the first place, they were very happy about it, because paper was only the source of, okay, let's say a carry bag or something. But when plastic was found out to be when the plastic was out, at the beginning, people were very happy that they had something to carry. But now we regret the decision, because the plastic pollution is taking over the ocean and everything. So basically, we'll have to make sure how we apply the solutions in the practical, understanding. So chemistry holds a very strong anchor to all the sciences to understand things around us better. I would end by that. All right.
All right, so this is just to spark your interest more in chemistry. I've included some notable figures who hold a bachelor in chemistry. So the first one is Margaret Thatcher, the former Prime Minister of United Kingdom. Next, we also have Kurt Vonnegut, the famous American writer. And the highlight of these notable figures is we have one over here, Tan Sri Emeritus Professor Dr. Augustine Ong, or better known as Father of Malaysian Palm Oil. Why? Because Dr. Augustine Ong is actually an alumni of University of Malaya. He did his Bachelor of Science in Chemistry and also his Master's in UM. And then he did his PhD in King's College, London. He is really well known, across the globe. He is internationally recognized in the field of lipid chemistry. So we can see very clearly here, chemistry can bring us more than what we expected. Not just limited to our own local place. Like, for example, if you are pursuing your degree in chemistry in Malaysia, that doesn't mean that you cannot go further and beyond that. And it is already been proven by Dr. Augustine Ong himself. So yeah, I found this is very inspiring. So I share it with you guys today. All right, next. Yeah.
Okay, this I'll take on over this slide. So because I'm already doing masters, as I've mentioned before, I finished my undergrad. I did applied chemistry, and I'm doing masters. I've already assigned my position as a chemist. I've taken a chemistry course, so I am already a chemist. So if you ask me why I am a chemist, because the first thing that comes into my mind is because I started watching Breaking Bad, and I started loving it, and then I was like, why not become a chemist? Okay, that was my whole purpose of it. No, I would disagree with that. That was part of a reason, but yeah, let's get into a serious note on why I really wanted to be a chemist. So basically, it's because we are curious about most of the stuff. And so to be curious and to be speculative, to be studying stuff, studying as in, like, you don't sometimes we have a notion of, study is like, you'll have to refer to your books, you have to study like, line by line. That's not studying. It's more of a learning process of how to study your, study your subject or field related, because I'm doing research mode, a master's. So every day there is one problem to be tackled in the lab. So I'll have to come up with critical thinking, problem solving skills. So all these are, it keeps me on my toes to, to a better day, to make myself better. That's what I do as a chemist. And let's go to the next question of what is the workplace of chemists like? As I've already mentioned, chemists. So what do you think they do? We always stay in our laboratory. Usually, yeah, laboratories. That's where our, our houses and all the machines are our, our child. Meaning, like, we have to take care of them. Meaning, everything that we do in the lab is like it has to be written down. It has to be jotted every day. So the workplace is most basically it's in the lab. And the day is like, as I've already mentioned, we get into the lab every day, we work with chemicals, a lot of chemicals. Particularly my research is based on organic synthesis, so I'll have to like work with chemicals on daily basis, and I have to work with NMR machines. We'll get into that part detail about, my research. Basically, this is basically it of a chemist. What they do on the daily basis is like, we analyze the chemical compounds, and we make sure that we have learned them better to practically apply them for any other applications. So that's what we do on daily basis. This is pretty much it as a chemist. Yeah. So the facilities in the campus, I just want to make sure, like, I've given you brief information on what I do. So what are the facilities? How do I, use all those facilities that has been provided? Is the main facility is the central facility, where, there are a lot of machines, because once you are done with your undergrad, let's say even during your undergrad, you will be using all these missions, because once you have already entered the field of chemistry, there comes a compulsion with it on how to study the chemicals. You just cannot, study the chemicals by just looking at the physical appearance, because there are going to be like, we need a lot of other machines to analyze them practically. So just by physical, okay, let's smell it. Okay, it smells of nothing sometimes, or it's very, it's colorless, the solution is colorless. There are going to be a lot of chemicals like that. So how are we going to analyze them? So we need equipments are the main, source of analyzing all the chemicals. So basically in we have all the equipments for research basically. And these are all, these has been like, organized in such a way that it's not an hustle to use them. And there is always training. Even for me, to use the NMR, there was a training session. So you are presented with, and using these machines. Okay, machines, definition of machine is, you know how to use a machine. If you know how to use a machine properly, you are well versed in it. So you will have to learn how to use these machines, and these facilities in the campus are amazing. And like, you can use any of these machines. So that is a plus point, because usually when it comes to research, if you don't have the right machines, you will have to use, machines from other university, or you'll have to link your research to the company, where it becomes, a kind of an hectic work schedule for you to, synthesize a compound here, go and check the, analyze the chemical somewhere else. So as long as the research and the facilities in the same place, you have the time to, do your research as such you planned. So it's like, it makes research life much better because of the facilities provided by the All right.
All right. So sadly, I'm not able to experience what Deepa has shared earlier, because as we all know, we are now in the pandemic situation, right? And I have actually never set my foot to the chemistry department. So I'm just gonna share my experience using online facilities that have been offered by the Faculty of Science, specifically Department of Chemistry. So yeah, like I've listed here, we have Spectrum, which is a platform for all UM students to get access to the study materials shared by the lecturers. And then, of course, we are using the WhatsApp or any medium that the lecturers want or prefer to use. And then lab, right? Because we know that science is more to the practical part of it. is important in science. So how do we conduct lab virtually? You might wonder that. So actually, this is a very, for me, is a very um, sad thing that is caused by this pandemic situation, because I still could not get the hands-on experience on working in a chemistry lab. So I just have the opportunity to learn on how to basically work in a lab later when we are allowed to go back to campus virtually by the lecturers. So yeah, and then other than that, we also have some kind of chemistry softwares shared by the lecturers, like ChemSketch, MolView, Marvin Sketch, etc. These softwares are used basically to see the molecules. Like if you want to draw molecules, we can use these softwares and analyze them better than we're drawing it by our hand, and much more. Actually, I just listed out a few here. Next. All right, so talking about challenges, like I've said before, of course, from the perspective of the practical session, for the lab session, I don't get the hands-on experience yet. And this is very disappointing because we're just looking at the methodology video on how to conduct one particular experiment and then just do report based on the videos and explanation from lecturers. So it is very challenging, to do a report based on something that you didn't do. You just watch a video and then you have to come up with a report just pretending like you are doing that experiment. So that's I think the most big challenges that I experienced as a first year in chemistry field. And then need to switch the mindset on orbitals, because in our high school we are not exposed to the concept of orbitals. I think this is actually experienced by most of the chemistry students, because during high school we are used to, like, for example, our teachers say orbits, right? We use the word bits, right? And then we say that the first orbits can only hold up to 2 electrons, and then 2.8.8. And then when you come to the university, you are told that that concept is wrong, and I was like, what? I've been learning something that is wrong all this while, because actually atoms doesn't work like that. It is much more on the quantum part of it and whatnot. I don't want to lecture about that to you guys today, but just want to share my view on that. How I approach that shift from something that I've used to in high school, and then when you go to a higher level in the tertiary level, all of those concepts you need to, like, reset and back to square one. Um, yeah, like I've said, need to switch the mindset on orbitals, and then need to be more attentive and not just to memorize, because in university life, you are actually taught to be critical, like what Deepa has said. We need to be critical, you need to solve problems and not just to memorize the notes like we're used to in high school. So this is also quite challenging. And of course, specifically in the midst of pandemic, I never have a face-to-face interaction with the lecturers. So I never actually know them. Like, yeah, we interact online, right? We interact virtually, but we don't really know each other well. We just have like reading text from one another, and we never have a face-to-face interaction. So it's like quite difficult for us to conduct our learning and teaching session. And also, I don't know much seniors because I don't go to campus yet. So I don't have much seniors to help me with my studies. I don't have much friends that have experienced this to ask questions about this course. So basically, I need to be more independent. And also, I don't get to know my course mates. Just, basically, like, we just say hi to whenever to whoever who are in our WhatsApp group, not knowing who she is or who he is. So yeah, basically this is my experience.
All right. Okay. The next challenge is from my perspective of, how I look at chemistry, or people who want to pursue chemistry as a career. You see, like, you get into any field, irrespective of, whatever you're choosing of your interest, there is going to be a, it's not, the path is not going to be bed of roses, it's not going to be smooth. It's always going to be, there's going to be ups and downs. So basically you'll have to understand the ups and downs. And it's always, particularly in academic fields, because you always, in academic field, the experience speaks a lot. Especially for me, I talk out of experience right now, because I've did my undergrad, I'm doing my masters. This has given me so much experiences. And how I got this experience is because I have interacted a lot with the lecturers that I had previously. So they gave me the knowledge, as well as they gave me the confidence to move on. So that's very much important. Whenever you don't know what you're doing, or when you are doubtful about your choices, it's always better to go speak to the lecturers personally. Am I doing this right? Am I doing this wrong? That will always break your comfort zone, and you will also come out of it. Meaning, like, you'll come out of it, and the communication skills will be improved. All these, you will have to make sure you're always out of this comfort zone, and you ask a lot of questions, irrespective of whether it is, the question is stupid or not. The questions usually, it's, there's a saying that goes, I'm requoting it, only at the point when you ask question you are stupid. You're not stupid, something like that. So you, as long as you don't know what you're doing, just it's better to ask for professional help, because they have a lot of experiences. So that's my first point. And the second point is, the challenge is, like, there are already a lot of challenges in science itself. So when you're going to get into the field of chemistry, particularly, as a person, as a chemist, I would say you should have the intrinsic motivation for you to proceed with the science. If you're not motivated, or if you don't want to contribute to science, or if you're not if you're not interested, it becomes a burden for yourself and as well as for science. That's what I mean by it. It's not that, like, usually anything without motivation is not going to get you anywhere. So basically you will have to know that. And particularly in science, the attitude, how attitude of how you react to science is very, it does matter. That's what I mean to say. Okay, let's say I'm like, I have had a very bad day. So I go to the lab, and if I mix two chemicals, it's not going to react because I'm saying I'm just in a bad mood. The chemistry is going to happen irrespective of how you emotionally react to it. So basically that's what I mean by it. So when to get into the field of science, there is no emotional connection to it, but you should have the intrinsic motivation and attitude. You should have a best attitude towards science. So understanding science. So what is, okay? I would like to concentrate most or more on what are the challenges that science has. So as you can see, I've quoted, one of the very well known. She's a professor at, Oxford University. She says that what should always prevail is the highest possible quality of science. From there all is possible. From there all is possible is that she means, like, scientific thinking lets you understand how to, tackle problems, irrespective of whether it is, a science problem or, a personal problem. The scientific thinking always lets you understand the problem better. Like, basically, sometimes when emotion plays role in it, you are not thinking properly, not necessarily, but then still. So scientific thinking always lets you understand the society better, and always it leads the path to, leads the path to a better revolutionized society. So that's what I mean by it. So that's the challenge in the science, where, we have to understand, like, understanding the challenges in science help us to understand the challenges that we are going to face in the future. That's what I mean by it. So basically there are going to be, like, for particularly for students, what challenges would be, as she has mentioned. Right now, if you get into the course, it's going to be like, it's sometimes it's going to be hard because of the COVID. Is like, we cannot judge things. So basically based on that, we have seen it, we she cannot come to the lab and all those stuff. So those are considerably minute things, but we'll have to look into in the future, and you have to understand that we cannot, control most of the things. So basically, very important challenges as a student I faced was like, from my personal experience, you should be we should all be taught critical thinking a lot. We should think critically, and you should have the problem solving skills, and you should learn how to work in a team, and you have to improve the communication skills. These four things are very important for a student to proceed on further with how to understand science better, and as well as to improve you better as a person, so that you understand science better. That's what I got for challenges. Like, all right, let's get into opportunities in chemistry. Okay, let's see. We had the sector is like, as we have mentioned, we have pure chemistry and applied chemistry, right? I did applied chemistry. Pure chemistry, the difference is not, I would say the differences in the courses is not huge, or it's not vast difference. So basically, we all learn the theory the same. The theory, okay, in chemistry, basically you would have known by now we have organic, physical, and inorganic. These three bases are very much important. So once you get to know that, that's pretty much it. And how you apply in the various field that I've listed here, we have agriculture and food, we have material, we have oil and petroleum, water, medicinal chemistry. All these they have the opportunity, irrespective of you do pure or applied chemistry, you're going to end up in any of these fields, and you're going to work as a technician, lab technician, always trying to use your critical thinking, problem solving methods in all these fields, and you're trying to make better machines or better chemicals for practical purposes and everything. So these are the areas of chemistry, and you can find the best. It's the opportunities in chemistry is like mostly based on experiences. So the hierarchy is always there, and these are mostly some of the applied areas of chemistry where you can get placed as a technician or lab technician. Particularly, you work in laboratories, yeah. And science we explore, yes. All right.
All right, so we're in the next session in science we explore. So as you can see here, there's a molecule, and actually it's not a new molecule, but it is developed more after the years, and finally we can say that we can use this molecule as a new weapon in the fight against COVID-19. So what molecule am I? Deepa, can you press? Yeah.
Yes.
So the name of this molecule is clofazimine, where this is an antibacterial drug. And like I've said before, it is not a new molecule. It has been developed in 1950s, and its original purpose is to treat tuberculosis or TB. But first, the first attempt it failed to serve its purpose, But few years later, it starts to show effectiveness against leprosy. And of course, this is with combination with other drugs. And today, specifically in this COVID-19 era, it is discovered that it kills the SARS-CoV-2 virus in hamster cells. And surprisingly, now this molecule or this drug is currently in phase 2 trials on hospitalized patients with COVID-19. So this pretty much shows us that chemistry or generally science always develops, right? It is a never-ending process. Although we see that like in the first place, it seems like it's not working out like we want it to be, but then we cannot we say that, oh, it's failing and I don't want to work on it anymore, because we always can find something new, and the molecule can always be developed. I mean, the potential of the molecule or the drugs can always be developed more if we work harder to find what is the uses of that particular molecule. Yeah, so basically this is it.
Right. Okay, in science we explore in this topic, I'll be talking a very little the basis of what I do in my research lab. So what I synthesis is like, my topic is bioanatomy glycolipids and cooperating charges for vesicular drug delivery. So these are all different terms here actually. So binary glycolipids. So basically, I work with surfactants. Surfactants are, like for example, let's talk about the soap or the detergents. All these are surfactants. Surfactants are something which reduce the surface tension or the interface tension usually, and that application can be used in various sectors. So basically, I am synthesizing one of the glycolipid, bionatory glycolipid. This is it. As you can see, I've put the picture here. So you can see this is a sugar molecule. Basically, I'm working with the most abundant sugar available, that is glucose. I'm working with glucose here, beta D glucoperoxidate, and this is the alcohol that's been attached. This is glycosylation reaction. I do this in the lab. So this is what happens. I synthesize it. If we don't want to get into detail, it's just that I'm telling you the basis, what I do. And why is it so much important? Okay, I've synthesized it. So what is it? Like I work in laboratory now. All right, I synthesize the compound. What is the application for it? So basically nowadays it's always more about how you apply things. It not necessarily you will have to always find a place to apply things. That can be usually that can be done by engineers. As a chemist, what we can do is we can also potentially tell the engineers that this can be used. Basically they'll try their best to try to apply. We just giving the hint, and they try to they try to deepen the concept and everything. That's what engineers are for. So let's get into this. So you can see here you have the glucose and the alcohol and the glycosylation reaction. And what it does is, so we use it for vesicular drug delivery. So we know what a drug is. So to take the drug, if you just take the drug, you are not going to just send the drug inside directly to where it has to react. And to solve the problem, what does a drug do? It relieves you from everything, relieves you from the pain that you're suffering from. So it has to reach the certain point of where the problem is. So to for the drug to travel, it needs a carrier, a drug carrier. That's why I've drawn this like drug-looking vehicle. So these binary glycolipids are going to be like carriers. They're going to be the wheels attached to the main portion of the drug. Why we use this is because this is considered as glycolipids. Lipids, they're easy. Lipids are something their lipids are fat. Once you take fat, it's easy for the body to take the fat and transport the fat everywhere, because even inside our body we have fats. So it's like the non-polar, it makes it easier to travel. So this is pretty much it. Is it pretty interesting, like to know what I do? It's because like when I got the topic of this is what I'm going to do, I was like fascinated about it. I was like, how is this happening? How am I going to do it? Like how the thing is, it's not I'm talking good about it right now. But when they gave me the topic, I was like, I don't know what I'm going to do. I was like, okay, I was in the point where like I wasn't sure of what was going on. It took me some time to understand, because so usually the master's research is done in 2 years, and PhD is done in like maximum of 5 years, 6 years. It depends on how much you finish. So basically, throughout in 2 years, you're asked to write the proposal in the first year, right? So in the first semester, basically in the first month you go in. So proposal is something that you tell them this is what I'm going to do, and people are going to judge you based on the proposal. So that gives you an idea of how you have written it. So basically, throughout these 2 years, you're going to learn a lot. So it's not about immediately producing the results, but it's about learning process. In science we explore, that's what it means. It's always about learning. So it's always about doing mistakes and not repeating them again. And sometimes mistakes can turn into happy accidents. Sometimes, yeah, I've read a lot of research papers on synthetic chemistry where they have just without knowingly they have added something to the reaction. The reaction has worked better than what they have planned for. So there are not always, but lucky, if you're lucky, there are always happy accidents. So that's why in science we explore. We always keep on exploring the science. Yes. Let's go into, I think the next is okay, NMR analysis. I just want to give you a okay. When I'm synthesizing compound, how do I know this is the compound? Usually, what I do is, as I mentioned, the importance of analyzing the compound. A type of instrument that I use is NMR analysis. I'm sorry. So NMR analysis, like based on the peaks, it's like too much of the chemistry, but I'm just going to give you a brief idea about what it does. So it tells us the protons, number of hydrogen atoms attached to the carbon. So based on that, I calculate all the values, and I'm like, I calculate and I see where the carbon atoms are, and there how many hydrogen atoms are. And this tells me, okay, what I have synthesized is the right compound that I've aimed for. So therefore, it is very important how you handle these, instruments very well, because once you know how to handle them, your works becomes easy, and then from there on, the research progress is like, it's very much easier to handle for everybody. So that's the importance of equipment, and is producing the best facilities. All right. Okay. Now, yes, we are entering our quiz time. Okay, who I think everybody is ready for it. Let's go for it.
Right. Deepa, can you read out the questions?
Oh, yeah, sure. Who is the notable figure mentioned before that was an alumni of and what is the title title that he is famous for? You can write the answers in the.
Yeah.
Oh, yes,
Yeah. We have
right.
a answer here.
Yes,
Father of Malaysian palm oil. Yes, yes,
yeah,
yes.
right.
You're right.
You guys are right. Okay, let's get into the next question. What is the name of the molecule that has high potential in becoming the drug that can fight COVID-19?
The name is so simple, actually.
Yeah, but for non-chemistry students, they can be like, still struggling on it, but yeah.
Yeah. They actually got it right. Yeah,
Yeah, you guys are right.
clofazimine.
Okay, the
All
next
right.
question.
Next question.
What is surfactants? Go on, it's a chemistry question. You guys have to answer this. Just, you can type out your. All right. Farhana, yes, you're right. Compounds that reduce surface tension or interface tension. Yes, that's pretty much it. All right. What's the next question? Okay, which is the simplest and abundant sugar?
Yes, glucose. Got it right.
Right. All right. All right. Okay. Yes. Last question. How do you wish to contribute for chemistry related field of studies? And if you're really interested, how do you like to contribute to it? Just I just want to look at the, uh, the the future aspirants of chemistry? Like, how do you like to contribute towards it? And there's no right answer or right answer, wrong answer. I just want to see the
Maybe they're typing out their long answers.
yeah. It's like you. It's not a one word answer, so it's basically
Yeah.
going to be a All right, I
Yeah.
got a Farhan. Okay, I'd like to create chemicals that can be used for multiple purposes, save cost, save resources. That's nice. That's pretty nice. By identifying new elements in the periodic table. All
And then put
right.
your name, right?
Yeah.
Put your name as the,
You
put
can
the
name the
animation
elements
as
and you
your
can find
name.
new elements. Yes, yes,
Yeah.
yes. Right, right. Okay, these are some creative ideas here. I would yeah, creating chemicals and creating new elements in the periodic table. I cannot wait to have these people. Be the best chemist in material design. Oh, nice. I wish you all the best. I like to contribute in a way that help protect the environment. Oh, I would really love to know, Reha, what are you going to do in future? Really, because environmental issue, climate change, crisis, the environment is suffering a lot than ever before. So I would really like to see what you're going to do. I wish you all the very best because each and everyone is you guys have the confidence on what you're going to do later. So it okay, there's another one. We hope that oh okay, Q&A segments. All right, we are into it. I think earlier I saw a question asking, what's the difference between chemistry and chemical engineering, right? I think I saw that. Okay, I would like to, until we get another question, I think we can discuss that maybe, if that's okay. So what's the difference between, chemistry degree and chemical engineering? Okay, the thing is, with chemical engineering degree, the students are, whoever is interested, they get a chemical application degree, meaning like, their theoretical foundation, everything is based on the theory, and they look little at the theory and more about the application. Whereas chemists, we look more into the theory and little into the application. Application is just part of it, and mostly we look at the theory. So as like for example, let's say chemical engineering, mainly it focuses on math and physics. A lot of you will have to deal with a lot of maths and physics. For example, fluid dynamics, distillation, absorption, all these membrane separation, all these comes under chemical engineering. But how these really happens, or the basis was set out by chemists. So you'll have to understand chemistry is like it's more analytical. You'll have to learn all the analytical, organic, inorganic, all these are separated always. And there is another side to it where we learn about biochemistry side, where the biology and the chemistry is both, both are there. So that's how usually it's done. Okay, we have got questions now. Okay, how do you find ideas for chemistry research? The ideas for research is like basically when you start. Okay, let me say from my experience. I'm talking wholly on my experience. My topic is not something that I thought I should be doing it, because as a young scientist, we don't have a lot of experience to analyze the topics. Meaning, like we don't have the research gap. We don't know where the research gap is usually. So basically, what we'll have to do is at the beginning, we'll have to be independent on the lecturers who are already in the research field. So what happens is, so I we always depend on the lecturers. So what we do is, they give us the topic on whatever research that they are doing. So basically, that's how it works. The researchers, the master's degree particularly, they'll give us the topic and we'll have to work on it. Once you have got the hold of it, once you have understand what is going on for PhD, you can submit. So basically, you can submit the proposal and see, and you can even get the grant sanctioned. It's a very big process. Even though if you have the ideas, it's always a big hustle, meaning not necessarily, it depends on how your ideas are. So that's the reason you have to talk with your lecturers a lot to understand how is your research idea, is your research idea valid, is there a research gap for that idea to be opened up or something like that. That's how it works usually for an idea. Okay, the next question is, if biology has biohazard, does chemistry have something irrelevant? The bad scientist, villainous side of chemistry, bioweapon like anthrax. Oh, interesting question. We're getting into the fiction of chemistry here. All right, let's see to that. Okay, there's a saying, it goes, anything that's used more than it has to be used, it becomes dangerous or it becomes poisonous. So basically, yeah, with the chemistry, it's pretty much the same. Let's talk about, Breaking Bad again. So if you use the chemistry aspect of it in a very in a unethical way, you're going to end up. So basically, ethics is very much important in science. You will have to understand the power that you hold. Science is very powerful. So you'll have to understand the ethics and morality of how you use your science. It's always like we always talk about science as in, like, for the betterment of people. But always it doesn't happen that way. The drugs consumption has been high as of any time in the world. So biohazard or bioweapon, there is always a talk about that. The villainous side of chemistry is like with the chemicals, the drugs, that's all I can think of right now. But yeah, it's better to understand the morality and ethics, as I've mentioned, of the science knowledge that we hold. Yes, that's my conclusion on it. Okay, that's a very interesting question. Thank you for making this session fun. Let's go to the next question. Why nuclear energy is not more applicable in medicine or technology sector, as it produces tons of energy compared to any viable resources. Nuclear energy. All right. From my experience of what I know about nuclear energy is, like, I just know a little bit. I am not a specialist in anything. So particularly of what I know of, with the knowledge that I can answer this question is that nuclear energy. Okay. Basically, to build a nuclear station, it's very what to say. It's expensive on the money basis. It's very much expensive. So it's like you will, as a nation, you will have to decide on which balance the socio-economic aspect has to be seen. To produce energy from a nuclear energy is like, it's easy, it practically it works. But to apply it practically, it works in the lab, a pilot scale it works. But to apply it on a large scale, that too in the for a nation, for an entire nation, to produce energy from it, it's not possible, because build a nuclear power energy is like, it's expensive in the first place, and it's also dangerous, meaning, like, if something happens in the nuclear energy station, things can get pretty serious. So basically, we'll have to compensate the safety, and as well as the money, and how is it very much important right now. But in far near future, I think we see the opportunity in nuclear energy to be like consumed much more, in much more larger scale than renewable resources. So I think that answers the question. If not, I would like you to ask people who are much more knowledgeable in that nuclear energy source of who are specialized in that particular source. And the next question is, in what year can I start to specialize in a certain field, and what are the options available? All right, Farana. Practically speaking, okay, so you cannot be very sure. If you're very sure about what you want to specialize right now, that's great. Because for me personally, from my opinion, I wasn't sure what I was going to specialize on at the beginning. But then when I found the topic that my supervisor gave me, it was very interesting to me. I was like, okay, now I'm getting into an organic chemistry based, organic synthesis based, research. So basically, that's how I found my field. Usually, if you know your field, sometimes the opportunities are available if you're lucky, and sometimes the opportunities are unavailable. It's always, I would advise, I would give you a tip. I'm not very good at advising. I would give you a tip. It's always better to be flexible and love chemistry as a whole. Like, usually sometimes we have an partiality towards, the courses. Some people might like organic more, or inorganic more, or physical more. But it's better to, as a chemist, it's better to always like these three equally, so that you would understand chemistry better if you know all these three aspects of chemistry well. So specialize in certain field, as long as your interest is there, the opportunity is there, you can specialize in any field: medicinal, organic, and what else can I think of? Petroleum based, as I mentioned in the slides. There are a lot of fields. You can just get into any field, as long as your theoretical and the practical skills in the chemistry field is superb. You can get into any field. All right. Next question. Can you elaborate more on the proper methods of storing certain chemicals and proper way of disposal of the chemicals? Uh, all right. This is much to the SOP that you will have to understand before you get into the lab. And I cannot answer this because there is so much detail to it on how to store the chemicals. And how to dispose them, because there are different type of waste and different type of setup for the chemicals that has to be stored under, not under the sun. They have to be always in a closed cabin. Strong acids, weak bases, all these we'll have to be very careful when you enter the laboratory. This is a very detailed answer, but I don't think I have the enough time to elaborate on the answer for this particular question. But there are a lot of resources out there. You can find the detailed SOP on how to maintain a lab and how to dispose the waste. I think you look into it further for your purposes. The next question is, in your opinion, why not just learn tertiary level chemistry during secondary school, but make it in a simple way, not too difficult? In your opinion, why not just learn tertiary level chemistry during secondary school, but make it in a simple way, not too difficult? Do you get it, Anis? I'm
Yeah,
not
I
really sure
think
about the question though.
um, I think he or she, I'm not sure, sorry, means that, like I've said before, right? In our high school, we are learning about the orbits concept, but then when we are
Yes.
entering university, we are shifting that into orbital. So I think he's asking, why don't we learn the orbitals concept earlier on, not the orbits concept?
Oh, I see. I think you can answer it if you want to, because I think you have understood the
Yeah,
question better, if you don't mind.
yeah. I think actually I think I'm on the same page as you. I think we should actually teach the students, like from the very beginning, the right thing, so that the challenge that I said I've experienced, the shift from orbits to orbitals, will not occur, because we already have the real, or I mean, yeah, the real basics or fundamentals of in chemistry. So the issues of shifting the ideas of orbits to orbitals will not exist. But then maybe the syllabus need to be revised back, and maybe they have relevant answers on why they are actually teaching that concept first, so that maybe it will attract the students' interest in chemistry more, because it's much easier to understand, right? Than the
Yes,
quantum
yes.
part of the chemistry. Yeah.
All right.
So, thank you very much, Ms. Noreen Hani Sohaira and Ms. Deepa Lakshmi, for a very insightful presentation about chemistry in UM and the American Chemistry Society, or ACS for short. So, Ms. Deepa Lakshmi, would you like to add a couple of things before we end the session?
All right. Thank you for giving me this opportunity, this platform to, just give a little bit of what I know about chemistry. And I hope I was informative and not too talkative throughout. But I think you have got the information that you all needed. And thank you so much for giving me the opportunity again. Yes.
Great, thank you. And Ms. Hanis, do you have anything to add?
Yeah, I just want to express my gratitude for giving me this chance to share, although I'm just a first year student, but still I have the share my experience, so I'm not in the campus. But yeah, thank you, and very great session with you all.
So, great. Thank you once again for your time and the effort you've put into your presentation today. And I'd like to ask, we want to take a quick photo. So please, a bright smile would be great.
Are you guys ready? Okay, give your brightest smile in 3, 2, 1. Okay, wait a minute. Another one in 3, 2, 1. Okay, thank you.
All right, thank you so much.
Great. All right. And for the audience, thank you so much for tuning in with us, and kindly fill out the feedback form uploaded in the live stream chat, because your response will be counted in choosing the winner for the best presenter. And our next session by Geological Society of Malaysia student chapter will begin at 10:30 a.m. on the very same channel. Till then, thank you so much for tuning in, and we will see you in a bit. Thank you.